All right. Now we are going to look at what happens when we take bond polarity and we put it all together, and we look at molecule polarity. Now, the term polar still applies to the same thing here. To have a polar molecule, we must have both a positive and negative end, right? The key here is both have to be there. Let me move my screen just a little bit here. There we go. Positive and negative ends, right? So you can't have two negative ends. You can't have two positive ends, which, by the way, sometimes you see. When you look at both ends of the molecule, you've got to have a positive end and a negative end. Now, it could be left and right, or actually, I'm looking on the screen now, and that's the right side of the screen. So, yeah, there we go, left and right. Or it could be right top and bottom, or it might be two diagonals where you have a positive and a negative, right? But you always have to have two ends opposite one another, one positive, one negative, right? So let me respond to this. What you're going to do is you're going to draw a molecule. So, for example, I'm going to look at, I've got two molecules I want to look at here. I'm going to look at H2O, and I'm going to look at CF4. So when you draw these molecules, these are molecules you already should have drawn. If you look at the shape, right, here's what you got to do. You got to look at the Vesper shape of these molecules. So there's the O and the H's, just like this. Remember, the Vesper shape of this is bent, right? If I was drawing this with the bond diagram, I might get this wrong, right? Because if I'm looking at the bond diagram, I might have drawn it like this. That's the bond diagram of this. Do not use the bond diagram. Use the shape. We have to do this from the Vesper shape, which is the whole reason for us for looking at the Vesper shape. All right, now what I'm going to do is I'm going to use blue. I'm going to show what the bond polarity here would be like. So whenever I look at this, and some people are going to be like, wait a minute, do I need to memorize all these numbers? No, don't memorize the numbers. If you need the numbers, they'll be given to you. But we can already tell because oxygen is right next to fluorine. I know it's going to be pulling the electrons away in this bond, right? These electrons in this oxygen-hydrogen bond are going to be drawn towards the oxygen. So here I am in a different color showing you the bond polarity of those bonds. What does that mean? Well, it means that in this bond, these hydrogens gives a partial positive charge, and the oxygen gets a partial negative charge. Now, it happens to be two partial negatives. We don't know if that makes up a whole negative charge or not, but it is definitely. And so when we look at this molecule, what do we have? Up at the top, we've got a negative. Down at the bottom, we have positives. So right here, this is definitely a polar molecule because it's got a negative end and it's got positive end. Negative and positive. All right? Easy enough. So that's what a polar molecule is going to look like. You're going to have a negative end and a positive end. It has to be done in the shape. So when we look at CF4, right, I'm going to switch back to the black ink here. We got carbon, we got fluorine up on top, we got fluorine down here, and then remember this one's tetrahedral. My dashed lines are not getting any better, unfortunately. All right, so we got fluorines and carbons all around. I already know, I'm not going to look at the table. I already know fluorine is the most electronegative element. Anytime it is bonded with some other element, it is going to be drawing the electrons away in that bond. So I know those electrons are all going to be drawn towards these fluorines. I'm going to draw this one right here. I'm going to draw this one right here, which means our carbon has a quadruply positive partial charge. And the fluorines all have partial negatives. Now, when I look at this shape, I notice the negatives over here at the left. There are negatives over on the right. There's negative up top, negatives on the bottom. Any way I look at this, I know there are negatives all around this thing. There isn't a positive end to this molecule. So believe it or not, this is a non-polar molecule. Even though it has polar bonds, it is a non-polar molecule because when I put them all together, we're not left with a negative end and a positive end. There's the positive part's all the way at the center of this thing. It's locked in that central atom. And it can't, right? We can't see that from the outside. We can't see that when we come at it from the outside. All we see are negatives all around this thing. So that is a non-polar molecule. And it's going to behave very differently. And tomorrow we're going to talk about what a non-polar molecule, right, what the effects are of that and what the differences between it and a polar molecule. We're going to talk about how these molecules might attract one another. And you'll see they're very, very different. So you should be able to take a formula, draw a bond diagram, and then tell me whether the molecule is polar or not. We're going to practice this a whole lot.